So our three conditions that we need to check before we can proceed is, do we have a random sample? If we're sampling without replacement, is the 10% condition met? And do we have an approximately normal sampling distribution? So we checked all of these, they all check out. Out here in the red pen, I'm gonna write why we need to do these. When you're actually doing a procedure, you don't have to say why or why it's important that we checked it. You just have to check them, but I'm doing this for the notes so you can be in the habit of knowing why we're doing it. So remember, with a random sample, we check that so we can generalize to the population. The 10% is so we can sample without replacement. And the large counts or the normal distribution is so we have an approximately normal sampling distribution. Okay, that's the reason all those conditions are important. All right, so that's the second C, check. The third C is the calculate. This is where the math comes in, all right? So if conditions are met, we perform the calculations. So with the confidence interval and with the significance test later, but with the confidence interval for one sample, we are always going to start with our general formula. And our general formula is that the confidence interval is a point estimate plus or minus a margin of error. Okay? The specific formula for this particular confidence interval, because it's a one sample Z interval for P, our point estimate is going to be a P hat. Our margin of error is going to be our critical value Z star times our standard error of our P hat. And then we just plug numbers into that formula. So our P hat was 0.56. We're doing a 95% confidence interval, so the Z star for 95% is 1.960. Then our standard deviation will be square root of 0.56 times 1 minus 0.56 over 50. And then we do the calculations on that to get our answer.